Hey guys, in this lesson, we're going to talk about the law of cosines versus the law of sines that we talked about in the last lesson. So make sure we're still kind of thinking about that solving frame of mind, but you also want to make sure that that we're not dealing with right triangles. I mean, I guess you can, but we're out of that realm, and that is definitely where our mind thinks is in the world of right triangles. So you're going to see all these scary formulas, which just push pause um, to get them written down. Um, but the thing is, I want you to think about this. Like, don't get too caught up in like the A, B, and C. So if you are solving for, let's say, C, this is the random formula. But know that everything else in this formula, it's like, okay, so you're trying to find the side length C, so you're using the other two side lengths that you have, and then the angle of C. So it's always going to be set up where you're going to have like side, angle, side. When you're using law of cosines, it's going to be like that. So you'll see that as we go along. So again, these are just variations of the same thing. So notice like b squared, you have the other two side lengths, and then the angle b. So these are all the same. So go ahead. I think I've kind of kept my screen on for a while so you can have a chance to copy down everything. Okay, so the first thing that I want you to do is set up a triangle given that information. Okay, so this is the what you should have right now. So we're missing the side length A, and then we're missing angle B and angle C. So I want to start off with this one. So I want you to go back to your angle measures. And again, okay, so we're gonna search for A, so we're gonna use this, but don't get too caught up into what you into this like formula. Just know you're gonna square each of the side lengths and then use this formula, which includes the angle of A. So let's make sure that we have the angle of A, and we do. So I'm just going to plug it in the formula, and we'll go from there. Okay, so I just plugged it in the formula, and I ended up getting this stuff. So from here, it's just a calculator issue. So when I plug all of this in my calculator, I get A equals the square root of 169, which ends up making A 13. I'm going to go ahead and fill that in down here. I have A equals 13. Okay, so now let's just try to find B. So angle B. So what I'm going to do is I'm going to go up here and notice how this is going to give me that angle measure. So I'm literally going to just plug in my values for what I have. So notice what I'm doing. I'm taking the other side lengths, the A and C, and then I'm subtracting the side opposite of B and squaring that. So again, I want to get, because we're going to get away from naming the angles here in a second. And so just don't get too caught up in that. But for right now, just go ahead and follow this formula. Okay, so I plugged it in the formula. And so this part is just like a calculator thing, and I ended up with 0.885. And then I took the cosine inverse of that. I actually keep this in my calculator, like the whole value. I just kind of round it off for you guys. So if you did round it off, it might be, your answer might be a little bit different than mine, but we should all end up about 27.8 degrees. So that is going to be my angle B degree measure. And then for angle C, you're more than welcome to do what you've been doing. But I think the easiest thing is we have, let's go up here. Oops. We have angle A and we have angle B. So I would just use like the sum of a triangle formula. So I'm looking for C. So I have 120 plus 27.8 plus C equals 180 to find that last value for angle C. And you should get 32.2 degrees. Okay, so for this next part, notice this is very, very general. So it does not give us any like A, B, or C. we're just going to like call it. So your A, B, and C might be different than my A, B, and C, but it's just how I chose to set it up. So I'm just going to call this A, B, and C. And again, like, I guess you don't have to. It just helps my brain kind of figure things out. I am literally going to just like call this side length A, B, and C. It does not matter if you switch those around. We're not looking for that. All we're looking for are 3 angle measures. So your angle measure B might be my angle measure A. So it's very, very general. So I'm just going to call this 6, 12, and 15. Just my choice. I do not have to do this. And then I'm just going to follow the formula. So notice, guys, I don't need, let's go back up here. I don't need any of like the side length formulas. I'm just looking at like these angle formulas. So I'm going to use the formula for angle A. So I'm going to go ahead and write these out so I don't forget. I'm going to find the formula or use the formula for angle A to find that. So I'm going to go ahead and write that and then show my work when I'm done. Okay, so I showed my work here. So this is just the formula, just plugging those numbers in, and I got 0.925. So I took the cosine inverse of that. Again, I kept, no, it ended up being just 0.925. So I took the cosine inverse of that, and I got 22.33 degrees. So again, like the way you set up your triangle, your angle B might have been 22.33. So it doesn't really matter. Okay, go ahead and do B and C, but just notice for C, you can still use that angle sum. So if I know this angle and I know this angle, I can subtract the sum of those from 180 and get this angle. So go ahead and finish up on this problem. So this is what I got for angle B, putting it in the formula. And then once I had A and B, I just added them together and subtracted that sum from 180. And I got that C was 108.2. Okay, for our last example, we are going to apply the law of cosines to parallelograms. So the first thing, let's go ahead and draw a parallelogram and kind of talk about its properties. So let's go in the problem. So we know that the side lengths are 10 feet and 15 feet. So I'm just going to call this 15 feet and 10 feet. So I know that, this is a hideous parallelogram, I'm so sorry. I know that if this side is 10 feet, this side is 10 feet, and if this is 15 feet, then this is 15. So think about it as like kind of like a rectangle that's been squished, and so the sides are kind of caving in. Also, it tells us that one of the angles is 68 degrees. So every parallelogram, you're going to have a pair of acute angles, which are the same, and a pair of supplementary angles, which are the same. And so the angles are, sorry, obtuse angles, which are the same, those angles are going to be supplementary to the acute angle. So 68 degrees plus the missing angle is going to give us 180. So when we do that math, we end up with these angles being 112. So that's how we're going to set it up. But this is messy. So they're going to ask us for the lengths of the diagonals. So I'm going to split it up. I'm going to draw a picture for each diagonal. So I'm going to maybe make this a little bit nicer. And I'm going to call that diagonal X. And then I'm going to, oops, I want to make that the same color. And that diagonal Y. So I'm just going to repeat like what I have up here, just kind of clean it up a little bit. So this is 10 and this is 15, little feet there. And so my purpose is I need to find this length. I also know that the angle that I'm dealing with is 112. And let's come over here and do the same thing. So this is 15, this is 10. And Oh my gosh, I'm a dork. I just realized that I made it the same way. Okay, let's try this again. There we go. Okay, and so this missing angle, that's my acute angle. So that's 68 degrees. So now I have my two diagonals that I can solve for. So again, think about like, go way back up here. I'm just gonna use, la la la. I'm just gonna use like this first one. So notice that I'm gonna use my other two side lengths and then the included angle that is opposite of the side length that I'm looking for. So just keep that in mind when you're doing that. Okay, so I'm gonna set it up. I'll keep you on here. I won't do it for myself. So I have x equals, so I'm gonna have side length squared, and then minus 2 times the two side lengths, and then the cosine of the angle. And so that's how I set that up. And so, la da 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 da, just type that all in your calculator. And once you take the square root, you're going to end up with about 20.9 feet for that diagonal. Okay, so I'm going to do the same thing. So kind of think about what I just said. So I'm just going to take my other side length. So I'm going to have side length squared, side length squared. I don't know why I flipped those around, same thing. And then minus 2, the side lengths, and then the cosine of the angle. So I hope you see that like when you're using law of cosines, it's set up that same way. So that's how we get those. Okay, so when you type that in your calculator, all of this and square root it, you should get about 14.6 feet. And so that is our length for that diagonal. And that is it.